Okay, I'm back with part 2 of this video. I had to step away because I had to go to boxing. But, what the fuck? Okay, so I did one iteration of this, and it passes all 65 out of 66 test cases, but it doesn't quite get to the thing. We checked ChatGPT, and it's saying to do a bunch of bullshit. I don't want to do that. I like doing things my way. So, I started with an in-order traversal. ChatGPT was telling me, so the hint it gave me was, you could have two trees that have a matching in-order traversal, but could still be non-identical, which I guess could make sense in some edge cases. So what I'm going to do is I'm just going to stack traversals. So here I had my function in-order trav, right? And then I had a length checker, and then I checked the components. So each individual element in the array, I checked that stuff after I checked the length. So technically what I originally planned for is, okay, check the length. If it's not the same, then check the in-order traversal. But what we found was it could be the same length and the same in-order traversal. There could be an edge case where that's true somehow. So what I'm going to do is I'm going to leave my code the exact same and just add another traversal. So I'm going to do in order and then post order. So that way, two traversals will guarantee a false. Because there's no way you can have it both ways. Unless there's some mega edge case that I'm not aware of. Okay. So what I want to do is I'm going to create a whole abstraction of functions. And I'm just going to make calls throughout this thing. So in order, stores 1, stores 2. We check that. I'm going to go stores 3, stores 4, stores 3, and stores 4. So what I'm going to do there is I'm going to store the next in order traversals. Because all this thing actually cares about is a true or false output. So it doesn't matter how many arrays I do. I can do fucking 20. And I'll still be able to produce a similar output because it just looks for true or false. It doesn't care about how many arrays I have. So I'm going to do here now. It's the exact same thing. So in order. Copy. Paste. So I'm going to just change this from in order to post order. Post order. And then in this case, I'm going to go from node.right, if node.right, and then node.left. So I'm just going to flip the directions. And then node.right. So if node.right, go right. So it's going to check the right side, boom, 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 and then check the left side. Right side, node, left side. For the in order is left side, node, right side. So root node. So I have that. And then I want to do another thing. So I want to do another check on my for loop again. Right? So for stores 1 and 2, right, it returns false. Right? So what I'm going to do is, because I'm lazy, I'm just going to copy paste, because the rule for code duplication is rule of 3, right? So if you do 3 things, so if I was to create 3 for loops that do the exact same thing, then I would try and abstract it and make it more efficient, right? But for the purposes of this easy problem, I'm going to go and just copy paste it, because if I was to abstract the for loop, I'd have to return the true or false back. Right, so that would be something I'd have to check, right? But if it's all in the same function, I could just return false and just end it there. So it just makes sense to just copy it. I'm not dealing with millions of data points here. So yeah, another thing is, this is another tidbit for you guys. You don't have to over optimize every little thing, right? If your solution only requires you to look at fucking 20, or let's see the restriction. Let's go to the constraints. 100 constraints at max. You don't need to optimize like that. You could just brute force the solution. It's the easier way. It's simple. It's easy to understand. So you guys understood that I did this first for loop. I'm just gonna do it again for stores 3 and 4. Stores 3. Stores 4. Len stores 3. Right, and then I'm gonna go, after I do in order, I'm gonna do post order. Post order trav. I'm just stacking more reasons for it to return false. Stores 3. So I'll be P post order trav P stores 4. Then I just gotta double check. Stores 3, 4, 1, 2. Okay, cool. If see, I could just duplicate again. Stores 3. See, and this is like a beginner friendly way. Anyone could do this shit. Takes no skills. We're just using logic. Boom. And then this should pass the test case. What? It's still outputs true? Why is it outputting true? What if I do it this way? Stores 4. Expected false. So I stacked falses and it still doesn't work. That to me is odd. Because an in order and a post order, what if I check if the arrays are identical? Check. Python. Comparing arrays with things, so comparing with numpy. That is interesting. Import numpy is n. One equals 2 dot all. It basically does the for loop, so I don't need it. That's odd. Because we do put every value in the array. So let's just add more test cases to it. Let's give the messiest solution. Look how far I have to go to be lazy. You may as well be diligent at this point. This is not a lesson to take away. Sometimes being lazy ends up making you do more work than you need to do if you did it the right way. Right, but if p-val equals q-val, I'm just going to go on the test case and just solve it here. Because right now it's returning true. I want it to return false, so I'm just going to test and then steer it towards a false the earliest way I can. So if the left node of the root node is not the same as the left node of the other root node, then false. Same thing with the right side. And technically you could just do that for every iteration. So like if you were to go in order traverse, if the left is not equal to q.left, then you return false. But let's take a look here. Run. What? If p.val is equal to q.val, the p.left is not q.left, return false. Okay, then all I have to do is just move the logic to the end. After all this, then we check the end. There's no way this is gonna work. 2 out of 66 test cases, okay. So we definitely can't do this, we're going backwards. So let's say we submit this. I'm just curious how I could make this solution work. Let's go to chat GPT. Make this solution work. Oh, I did the post order wrong. Okay. I just have to swap these. So let's, oh, this is my actual thing. Let's just go to here and swap this. This should fix the issue. This is what they're telling me to do. X. Run. Submit, and this should work. What? It's still not working. Why? Well, yeah, I have a base case, so I don't need to have this if statement anymore for the top either. But it fails more test cases, so I could just leave it. I'm gonna put output here. My code. Output. My code. The primary post order trav it incorrectly calls in order trav. So performing a true post order traversal. Additionally, you should incorrectly call it twice on P. Oh shit, I did it on P twice. See, look, it's like 11:49 at night. So like this ChatGPT is actually not good for writing code. It's just good for finding my errors. I did it on the same array twice. Okay. So that means my actual solution should have worked originally. I just fucking had a typo. Okay. Now it's gonna work. What? Oh, it still doesn't work. Why? Why doesn't it work? Okay, here's the correct implementation. Okay, so it stores 3, 4. False, false. False, false. Okay. Nodar. Based on the structured node values. Okay, what do you mean it incorrectly calls in order trav? Did I mess up something else? Post order trav. Oh, that's what. It's because within my recursive function of post order trav, I'm calling in order trav. So that means if I fix this originally, this is another thing with copy pasting. You gotta make sure everything you've copy pasted. So like I originally copy pasted my original in order trav, and that's what threw this off. So let's try running it now. Now it should work. Now it should 100% work. It should 100% work. Did you see this? I'm a fucking genius. It's like, okay, ChatGPT, all it did was find my typo, but my logic still stood. So like my logic was basically, I had the in-order traversal and I had the length of the array, right? So if I had those two things, one, if it's not the length, disqualify right away. If it's the in-order traversal, then compare each element and see if it's the same, and that should eliminate most things. So it did work for 65 out of 66 test cases, but there is an edge case if, for example, you have nulls or something. You could have in-order traversals that are the exact same, even though the tree structure is not the same, right? So that's a super severe edge case. So what I thought about to combat it was, okay, let's do a post-order traversal, right? So that way, if I have an in-order traversal and a post-order traversal and a length check, 2 length checks on my post-order and my in-order. So if you look at here, it's stores 1 checks the length of the in-order traversal, stores 2 checks the length. So I have 2 length checks and 2 traversals to compare, right? So there's no way the structure could be the same now. It's like it eliminates like 99.99%. Right, so then what I did was I just took this, copied it, my in-order trav, and then I forgot to change this this in-order to post-order when I did that. So that's what kind of held up the solution. But if you look here, we were able to solve it. We didn't have to use the ChatGPT method of the ChatGPT original method to solve was you have to go through each node, check the left and the right subtree. Then go to the next step, check the left and the right subtree. And then you do that simultaneously between both the trees, because you're given 2 root nodes. So instead, I'm just like, fuck that. I just want to copy paste and brute force it. So I'm just going to do it for in-order traversal, copy paste it, all the logic, and then just do it again for post order. And that solves the issue. So if you look here, it beats 78.78% of other solutions, right? And it only took 15 milliseconds for runtime, 11 milliseconds for runtime. So the test case for the 3 is 15. This says 11 milliseconds for the runtime. So even with 100 data points, this is fast. The only thing is it takes O of n time complexity, because you have to go through each element when you iterate, and then it takes O of n space complexity, because you have to stack on the call stack using recursive functions, right? So O of n time, O of n space. So yeah, it does scale with the input, right? There's someone, if you were to do it with a while loop or something, you could probably reduce the O of n space for the call stack to, well, it would still be O of n because you have to create your own stack. So it would be around the same thing. This is the easiest way we could solve it. As you can see here, 2 sets of arrays, 2 sets of function calls, 2 sets of length checks, and you know, as your boy Big Daddy Tate says, man, 2 coffees, bro. You need 2 coffees for the solution. So, like, yeah, that's about it. So that's this part 2 of this solution for the problem. So if you like the video, please give it a thumbs up. Please leave your comments in the description below, or please leave your comments below and I'll get to them. And I'll try and implement the feedback as I keep progressing through these videos. And yeah, don't forget to subscribe. And that is all for today. The Knologist is out.